This is a series on the general linear model, and this is the final video in this series in which I'm going to talk about extensions of the general linear model. Actually, it's not extensions of the general linear model, it's extensions of the designs that we have seen so far to other designs, all using the general linear model and all because of that model. The general linear model is general, so that many different models are possible, with each model corresponding to a research design. So in addition to the designs that we looked at as examples, one could envision more factors or covariates. You could have more between subjects factors. You could have more within subjects factors. You could have some of each. And you could have more than a single covariate. You could have multiple covariates. You can also have combinations of experimental and observational variables. Many of the designs we looked at I referred to as randomized designs, but I also made the point that perhaps they wouldn't be randomized, that they'd be observational, and that you could also have two factors or more in which some of the factors are randomized and some are observational. So you can have all combinations of both experimental and observational variables. Sometimes in our designs, even when we can randomize, we put in a variable as a factor that we cannot randomize on just to remove the variation due to that factor because we think it's important. That is, we think that it is related to the response measure. We can have cross-sectional designs, those are between subjects, and longitudinal designs, those are within subjects, and as you know, we can have mixtures of those. Whenever we have these designs, we create a model, and the model has all of the effects from the design incorporated into that model. Researchers are interested in estimating each term, that is, each effect in the model, and we can estimate it through description or point estimate, and if we have met the conditions for valid inference, we can make inferences with interval estimation with a specified level of confidence. So the designs that we have looked at, they are just the beginning. You actually could conceive of all sorts of variations in which you vary the numbers of factors, in which you vary the number of covariates, in which you vary whether you have randomization or observational variables, in which you vary whether it's between or within subjects. But regardless, the model should contain in it a term for every effect as well as for at least one residual. And then we're interested in doing point estimation of those effects, that is description, and we're interested in seeing if we can make inferences about those effects. We can also usually have graphical displays to illustrate the effects, and I like graphical displays and description both. And then if we in fact see an effect that we want to try to infer, hopefully we can meet the conditions for valid inference and infer those effects outside of the study.